And we're back with another video request for some operations with radicals. These are actually operations with exponents questions, but some of the properties of radicals are going to be useful as well too. So here we have the fourth root of 18 times the fourth root of 9 divided by the fourth root of 2. What we can do is we can break the fourth root of 18 up into two fourth roots, because 18 is actually 9 times 2. So it's going to be the fourth root of 9 times the fourth root of 2 times the fourth root of 9 over 2, the fourth root of 2. Now, the reason why I broke that up in that particular direction is now I can take this radical and distribute it over each of the products in the radicand. So this is the fourth root of 9 times the fourth root of 2 times, again, the fourth root of 9, all over the fourth root of 2. Now, the fourth root of 2's will cancel out, and I'll be left with the fourth root of 9 times the fourth root of 9. Now, I can write, there's two of them, so I can write this as the fourth root of 9 squared. And now I can combine or change this radical to rational exponents. So remember, the denominator of the rational exponent is the index, and the numerator of the rational exponent is the power that it's raised to. So this is going to be 9 to the power 2 over 4. Now 2 over 4 is 1/2. And I'm going to do this funky trick where I'll actually change back now, because I'll have the square root of 9, and the square root of 9 is 3. Now, there's more than one way to get to this particular answer. Up here, we could have changed 18 to just 9 times 2 and wrote them both to an exponent of 1/4 and 1/4, and wrote 9 to an exponent of 1/4, and wrote 2 to an exponent of 1/4. So converting directly to rational exponents may have made this cancellation easier. And then 9 to 1/4 times 9 to 1/4, you add the exponents because you're multiplying powers with the same base, and you'll see we get down to 9 to the 1/2. The next question that I was asked for on this particular set of problems was dealing with the volume of a cube. So this is a fun question. You can do this on your calculator, but it's a lot easier to do without a calculator. So the volume formula for a cube is just the side length cubed. And we've been given a volume of a cube as 0.01565. Now, when I see 15625, I'm instantly thinking of a power of 5, but I'll hold that off for a second. I'm going to write this as 15625 times 10 to the power -6. And that's going to be equal to s cubed. Now, I wrote 10 to the power -6 because I'd have to move the decimal place 6 spots over. Now, 15625 is going to be 5 to the power 5? 25? 25? 125? 625? 2, 3, 4. 5 is going to be in the 3s, so 6. It's actually 5 to the power 6 as well. So 5 to the power 6 times 10 to the power -6 is equal to s to the power 3. Now, if I want to find the side length, not the side length cubed, I just have to take the cubed root of each of these. Now, that can be established by doing a cube root in this way. So I'll do the cube root of 5 to the power 6 times the cube root of 10 to the power -6 is equal to s. Of course, I can write these as rational exponents now. So it's 5, 1 over 2, times 10 to the -1 over 2. This is equal to my side length. Now, I just did -1 over 2 because I've got, that's 10 to the 2 here, and 5 to the 2 here. And I do apologize. 2 and 2, because this is the numerator and this is the denominator. And this is negative because we have -6 over 3. Now 5 to the power 2 is 25. 10 to the power -2 is 1 over 100. And so multiplying gets me 1/4. And so the side lengths are 1/4 of a meter. And that's it for this question. We would probably make a statement, but my chocolate chip cookies are burning, so I'm gonna finish this off later.